Good day, everyone. I'm Sir RJ Layson, your math tutor and guide on this exciting journey through the world of numbers. In this video, we will discuss all about direct variation. Direct variation is our first lesson in the quarter 2 under variations. There are four topics that we need to discuss in the variations. We have direct variation, inverse variation, joint variation, and combined variation. Now, let's define first what is direct variation. There is a direct variation whenever the situation produces pairs of numbers in which their ratio is constant. The statements y varies directly as y is directly proportional to x and y is proportional to x. These are the statements in the direct variation. It can be translated mathematically as y equals to k times x, as then the k there is the constant of variation. For two quantities, x and y, so it depends also in the variable given. Not necessarily we will use y and x are in our two quantities as variables. It can also, you can use a, b, or z, x, anything. An increase of x causes an increase in y. Well, similarly, a decrease of x causes a decrease of y. That means their two quantities are directly proportional. Increase of x, the y also must increase. Or a decrease of x, the y also decreases. Again, direct variation, all you need to remember that whenever your x and y, x increases, your y also increases, and then if your x decreases, your y also decreases. Both of the quantities are directly proportional. So there are steps in solving direct variation. First, we need to write the variation equation. We can use y is equals to k times x, or k is equals to y over x. Next, we need to substitute the given values to find the value of k, that is the constant of variation. Next, we need to rewrite the variation equation y is equals to k times x with the known value of k. And lastly, we need to substitute the remaining values to find the unknown. Let's have example number 1. If y varies directly as x and y is equals to 24 and x is equals to 6, find the variation constant and the equation of variation. Now, in writing the equation, you will use the statement here, if y varies directly as x. So first, you will put y there, y equals, but that means varies, that is the k, and directly as x. When you say directly, that means you need to multiply. So y varies directly as x. So we need to express the equation y is equals to k times x. Step number 2, we need to solve for k by substituting the given values in the equation. So we have y is equals to 24 and x is equals to 6. So we have here 24 is equals to 6k. Divide both sides by 6, we will get k is equals to 24 divided 6. So 24 divided 6, we have our constant variation is equals to 4. The constant of variation is 4. And then step number 3, the equation of variation will be, we just need to substitute the value of k, y is equals to 4x. So step number 4, in this question, we don't need to solve this one because we're not asking for the missing value or the unknown value. Let's have example number 2. If y varies directly as x and y is equals to 28 and x is equals to 4, we need to find the variation constant and equation of variation. Again, step number 1, we need to express the statement y varies directly as x as y is equals to k times x. So we have here, substitute now. Step number 2, we need to substitute the given values in the equation. So we have y is equals to 28 and x is equals to 4. So we have 28 is equals to 4k. Divide both sides by 4, we have k is equals to 28 over 4. So 28 over 4, that is 7. So that means the constant of variation is 7, and then the equation of variation is equals to y is equals to 7x. Okay, let's have this example. The table below shows the points P earned by the grade 9 class for every number of n of kilogram of waste paper collected. Find the constant of variation and the equation of variation which describes the relation. Now you look at the table, the upper row, the number of kilogram, we have here 1 kilogram, 2 kilograms, 3 kilograms, 4, 5, 6, 7 kilograms. And we have the lower row, we have the points. For 1 kilogram, we had 10 points. 2 kilograms, we have 20 points. 30 points, 40 points, 50, 60, 70 points. Now here, since we have, when you look at you analyze first the table, no? You look at the value of the number of kilogram. Okay, let's say that is the x. So as you can see, the value of x increases, and also the points, let's say that is y, the value also of the y is also increasing. So that means this problem is considered to be a direct variation. So we need to express the statement since we have here P and N. So we will use P varies directly as N. So that means we have P is equals to K times N. Step number 2, we need to solve for K. We need to substitute the given equation. So how are we going to substitute, no? So we need to pick just one point or one pair of values there. So you can select 2 and 20. You can select 3 and 30, 4 and 40, 5 and 50, 6 and 70, 7 and 70, or 1 or 10. Okay. For this example, we will use 3 and 30. So substitute. So we have n as 3 and p as 30. So we have 30 is equals to 3 times k. Divide both sides by 3. So we will get k is equals to 30 divide 3. So 30 divide 3, we have our constant of variation, we have 10. So that means our equation of variation will be P is equals to 10 times N. Now, if you will use other pair of values, or you can consider 4 and 40, 5 or 50, you will get the same answer. You will have the constant of variation is 10. Now, if you had time, you can try it in your notebook. You can write it and answer. Example number 4. The table below shows the distance varies directly as time. Find the constant variation and equation of variation which describes the relation. So we have here the table, the time in hour 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, 6 hours, 7 hours. And the distance per hour, so we have 15 kilometers, 30 kilometers, 45 kilometers, 60 kilometers, 75 kilometers, 90 kilometers, and 105 kilometers. Now, the question is this a direct variation question or table? So we have here, if you look at the time is increasing. The distance also is increasing. That means we can verify this table or this given problem a direct variation. Again, what is direct variation? An increase of x is also an increase of y. That is, both quantities are directly proportional. Okay. Now, let's express the statement d varies directly as t. So that means we have d is equals to k times t. And then solve for k by substituting the given values. So we have here, now again, how to find the constant of variation here. We just need to use a pair of values. So in this example, we will be using 2 and 30. And again, you can use any of the pair of values in the given table. So we have our time there is 2, and then our distance is 30. So we have 30 is equals to 2 times k. Divide both sides by 2. we will get k is equals to 30 over 2. So 30 divided 2, we will have k is equals to 15. That means the constant variation is 15. And then the equation of variation is d is equals to 15 times t. Okay. Example number 5. Here, in this example, so we will be having a missing or unknown values. So if x varies directly as y, and x is equals to 35 and y is equals to 7, what is the value of y when x is equals to 25? Now first, we need to find here the constant of variation by using x is equals to 35 and y is equals to 7. After finding the constant of variation, we can now find the value of y by substituting the constant variation and the value of x is equals to 25. So step number 1, so same, we need to express this one. So this example, no, x varies directly as y since x is in a stage first, so we will use that. We will write that one first. The x is varies, so we have k directly as y. So when you say directly, you just need to multiply, and then we need to find the value of k by substituting x is equals to 35 and y is equals to 7 to the equation. So we have here 35 is equals to 7 over k, 7 times k. Divide both sides by 7, so we have k is equals to 35 over 7. So 35 divided 7, we have k is equals to 5. And here also, we will have two solutions. You can use either of the two. Okay, so let's proceed sa. So therefore, the constant variation is 5. So we have here the constant of variation is 5. So the equation of variation now is x is equals to 5y, or 5 times y. So now, we need to now solve for the missing y. So we will use the equation equation of variation x is equals to 5 times y, substitute the value of x, that is 25. So we have 25 is equals to 5 times y. Divide both sides by 5, we will get y is equals to 25 divided 5. So we have 25 divided 5, we have 5. Y is equals to 5. Hence, we have y is equals to 5. Now, in the solution number 2, so since we have x over y is a constant, then we can write as k is equals to x over y. From here, we can establish the proportion. So x sub 1 over y sub 1 is equals to x sub 2 over y sub 2, where your x sub 1 is equals to 35, y sub 1 is equals to 7, and your x sub 2 is 25. Now, the missing value here is the y sub 2. So now, we need to substitute the given values. So we have 35 over 7 is equals to 25 over y sub 2. Cross multiply, you will get y sub 2 is equals y sub 2 times 35 is equals to 7 times 25. 7 times 25, we have 175. To isolate the y sub 2, we need to divide both sides by 35. So we have here y sub 2 is equals to 175 divided 35. So 175 divided 35, you will get y is equals to 5. Therefore, y is equals to 25 when x is equals to y is equals to 5 when x is equals to 25. Okay, you can use solution 1 or solution 2. It's up to you. As long as you are comfortable of solving, okay? Any of the two. Okay, we have our last example. If z varies directly as y, and z is equals to 40 and y is equals to 8, what is the value of y when z is equals to 35? Now, you look at the statement, we have z varies directly as y, so you will write first z is equals to k times y. Now, we need to solve for the given values of the equation by we need to find the constant of variation by substituting z is equals to 40 and y is equals to 8. So we have here 40 is equals to 8k, divide both sides by 8, you will get k is equals to 40 divided 8. now we have the constant of variation as 5. Then, now to find the value of y, what is the value of y when z is equals to 35? So you will use now the equation of variation z is equals to 5y. Substitute the value of z there, 35. So we have 35 is equals to 5y. Divide both sides by 5. You will get y is equals to 35 over 5. So you have y is equals to 7. So that means, hence, your y is equals to 7 when your z is equals to 35. Now, solution number 2, since z over y is a constant, we can write k is equals to z over y. From here, we can establish the proportion such that z sub 1 over y sub 1 is equals to z sub 2 over y sub 2. Z sub 1 now is 40, y sub 1 is 8, z sub 2 is 35, and our missing value here is y sub 2. So substitute the givens. So we have here 40 over 8 equals to 35 over y sub 2. Cross multiply, you will get y sub 2 times 40 is equals to 8 times 35. 8 times 35 is 280. We can divide both sides by 40 to isolate y sub 2. So we have y sub 2 is equals to 280 divide 40. So y sub 2 now is 7. So that means, therefore, y is equals to 7 when x is equals to 35. Again, you can use either of the two in solving the missing values of the direct variation. Okay, again, we need to remember direct variation is, that means the two quantities are both directly proportional. An increase of x is also an increase of y, and then a decrease of x is also a decrease of y. So in the graph also, if you have a given graph, that means your graph must be increasing or decreasing. They are both increasing and decreasing. Okay, thank you so much guys for watching my video lesson. I hope that you've learned many things, and you can know how to you can now solve problems involving direct variation. That's all for today, and see you on my next video. God bless everyone. Goodbye.